Good evening, sir. My name is Vineeth Victor, and my registration number is 19BC1792. And the topic for digital assignment 2 is Apriori algorithm and its simulation using a software called RapidMiner. Now, what is Apriori algorithm? The Apriori algorithm is an algorithm for mining frequent item sets for Boolean association rules. Apriori uses a bottom-up approach where frequent subsets are extended one item at a time, which is known as a candidate generation, and groups of candidates are tested against the data. Now, I wish to explain this with the help of an example. Now, let's consider a database with 5 transactions. The minimum support for this is 60%, and the minimum confidence level is 80%. Support and confidence will help us to know how frequently an item set occurs in a particular transaction in this particular data set. So we can see these 5 transactions and the item sets: monkey, donkey, make, and mucky and cook. So the first step we have to do is to find the support value, which is basically calculated by with the help of the formula support is equal to support by support plus confidence times the number of transactions. And after calculations, let us set the value as 2.14 for the sake of this example. And here the support stands for the number of times this item set occurs in the transaction. So what I mean by that is, if I take the first row, that is M, and I can see that the support is 3. If I go back to the database, I can see that the letter M occurs in 3 transactions: the first one, the second one, and the third one. If I check the same thing for the second value in the item set, that is O, I can see that O occurs in 3 item sets: the first one, the second one, and the third one. It occurs in 3 different transactions. The same thing can be said for N, which is shown to be 2, and N occurs here, and N occurs in the second transaction as well. So we could do it for the rest of the values in the item set, and the support values are found. Now, we have already fixed the minimum support value as 2.14. So we have to reject all the values that which are lesser than 2.14. So we reject the third transaction as it's less than 2.14, and we reject all these items transactions as well since they are below 2.14. And after rejecting those values, we make the new table, a new transaction table with the remaining transactions for further study. So we get M, O, K, E, and Y, and we have the support as well. And the same thing is done again, but this time we take 2 values in the item set. So we have MO, MK, ME, MY, OY, etc. And we calculate the support, how many times M and O occurs in the item set. And so we find the support values like that. And then as we have done before, we reject all the values below 2.14. So same story here. We reject the first transaction, which reject the third one, fourth one, this transaction, and this transaction. We reject all those values, and we form a new transaction table again. Now with all the updated values greater than 2.14. And after this, the next step is to take 3 values at a time. So we take M, O, and K in the candidate 3 table, and we continue and 4 values as well. So we we repeat the same process again with these values, and we find the support values, which are found to be 1, 2, and etc. And we repeat the same thing again. We reject all the values lesser than 2.14, and we see that all these item sets, the transactions, do not make the cut, so they are thrown out, and we get only 1 transaction which is of our interest. And we form the association rules for that particular transaction, which is OKE. and the support is 3, and we check for O in K and E, K in O and E, and the letter E in K and O. So we find the confidence values for these transactions. Confidence here is the total confidence by the total support it had, and we see that the we find the confidence percentage, which is 100, 60, and 75. And we have already set 80% as the minimum confidence level before starting all this process. So we can reject 60 and 75 as they're below 80%, and we finally get 0. O gives KE as the required value. This is the pseudocode for the a priori algorithm. And we first use K minus 1 item sets to generate the K item sets. Then we find C of K by joining the two tables, and then we prune it by removing all the values lesser than than the value calculated, and then we repeat the process until we find the association rules. Now I would like to simulate this with the help of this software called RapidMiner, and the data set I've chosen for this is grocery data set. And we see all these rows. Each row is a transaction, and these are the values. Yeah. So we have milk and bread. So all these values: milk, bread, and biscuit, bread, milk, and biscuit, etc. All these are basically transactions made by customers who visit a store. So a first customer might have bought milk, bread, and biscuit. The second customer might have bought bread, milk, biscuit, and etc. And these are basically different transactions made by the customers. And going back, so the first thing that I've done is to import data set, and I've shown the data set. And then since the data is in its raw form, we are required to vectorize it. And so we use text vectorization for it to vectorize the data. And after that, the next operator, it's numerical to binomial, and what it does is it basically converts all the nominal attributes to binomial types, and it maps all the values to the binomial values. And it can be either true or false. And after that, we connect it to the next operator known as FP growth. So before that, I would like to explain this further with the help of an example, numerical to binomial operator. So suppose we have a nominal attribute called cost, and the cost can be high, it could be moderate, it could be low. And if I have a sample data set, and then one of the cases will be true and others will be false. Okay, so after that, we move on to FP growth. So what FP growth does is that it calculates all the frequent item sets from the given example set using a tree data structure. And the input here is the example set that we have chosen, which is the grocery data set. And the output is the frequent item sets. And input also should be binomial. So the input has to be in binomial form. And that's one of the reasons that we chose this operator before it, the numerical to binomial operator. And after this, we included the last operator known as create association rules. And what it does is it generates a set of association rules from the given item sets. So so we can set the different values here. I've set the criteria to be confidence because that's what we saw in the example. And the minimum confidence is set to 60%. This could be changed, of course, but for the sake of explanation, I chose 0.6. And when we run this, we get all this. And yeah, in the description, we see 5 association rules. And what this conveys us is, let's say a customer buys sugar from the store. He or she is more likely to buy bread along with it. And the same way, if a customer buys cornflakes from the particular store, he or she is more likely to buy coffee along with it. And the same thing for sugar. If a customer buys sugar, he or she is more likely to buy coffee with it. And same thing for milk and bread. And we can visualize this with the help of a graph as well in the graphical form, and we see the data. So what are the advantages of a priori algorithm? So first thing, it's easy to understand, it's easy to digest. And the second point is it joins and prunes a step of algorithm, and it can be implemented on large data sets. Then what are the disadvantages of a priori algorithm? The a priori algorithm works slow compared to other algorithms. The overall performance can be reduced as it scans the database for multiple items. And the space complexity and the time complexity of a priori algorithm is also very high, which is order of 2 raised to n, which is very high, and n represents the horizontal width present in the database. And how is this helpful for, how is this applicable in real life situations? So with the help of this data, the shopkeeper can easily predict what the customers are interested in, what the pattern is in his store, what happens on the day-to-day basis, what do the customers buy, and he can identify patterns, and he can help to boost his sales on the long run. So thank you so much.